Morning, guys. Right, so we are going to have a look at the homework from Monday, which was based on. Sorry, I'm trying to find it on my iPad. It was based on all four of the patterns. Yeah. Okay. Now, I'm going to go through this sort of the long way because I want you to see the process, but obviously if you spot it quicker and you know which one it is. Now, like I said, you have to show your work, but it's fine to kind of not go through the process if you can tell what the first one is before we even start. Okay, 256 and 1024. Okay, so I'm going to grab my calculator. Okay, so I'm going to look at the first difference because I want to check if this sequence is linear. So to get from 4 to 16, that's plus 12. So I'm doing 64 minus 16. And then that means it's a jump of 48 to get from 16 to 64. I'm going to do 256 minus 64. So that is plus 192. And then 1024 minus 256. So that one is plus 768. Okay. So we do not have a common first difference. So that means that the sequence is not linear. Okay, let's go second difference. So 48 minus 12. Oh, sorry. That gives us a jump of plus 36. 192 minus 48 is a jump of 144. And 768 minus 192, that's a jump of 576. So we have no common second difference. So my conclusion there is that it's not quadratic. Yeah. So I'll check my third difference. So 144 minus 36. Black. That's a jump of 108. And 576 minus 144 is a jump of 432. So I have no common third difference, which means it's not cubic. So I've ruled out three of them. So it has to be exponential, but again, you can't just say that, you have to prove it. So remember, exponential is the multiply one. So I need to go from 4 to 16, and I want to know 4 multiplied by what makes 16. So the way you check that is you do a division. So 16 divided by 4 is 4. Next, we're going from 16 to 64. So what do I have to multiply 16 by to get 64? You check that by doing 64 divided by 16, which is 4. Looking good. Next one, what do I have to multiply 64 by to get 256? So 256 divided by 64, 4. And the last one, 1024 divided by 256, multiply 4. So I have a common ratio, which means this sequence is exponential. So that's the first one. I'll just put an E for exponential beside it. Okay, so I'm just going to take down the second sequence and then we'll do it. So 3, 5, 18, 44, 85, and 43. Okay, here we go again. So, first difference, 3 to 5, that is a 2. 5 to 18 is 13. 18 to 44, I'm not sure about that one, so I'm going to do 44 minus 18. It's 26. 85 minus 44 is 41. And then 143 minus 85 is a jump of 58. Okay, so I have no first difference. So that means it's not linear. Okay, go second difference. So 2 to 13, that's 11. 13 to 26 is a jump of 13. 26 to 41, I don't know, so I'm going to do 41 minus 26. So that's 15. And then 58 minus 41 is a jump of 17. So we have no common second difference. So that means this sequence is not quadratic. Just realized I left the word common out here. Right, so we go cubic. So from 11 to 13, that's a jump of 2. 13 to 15, 2. 15 to 17, 2. So we have a common third difference. So that means the sequence is cubic. So go back over here and just put a C beside that one. Okay, but again, I've proven it with my work. This is not just me putting E and C beside these. You must show your work. All right, so the third one. 11, 15, 19, excuse me, 23, 27, 31. Okay, here we are. Let's look at the first difference. So 11 to 15 is plus 4. 15 to 19 is plus 4. 19 to 23, yay, plus 4, plus 4. So we have a common first difference. So this is a linear sequence. Much quicker when it's linear. So there's your linear sequence. So the last one should be quadratic, but again, we have to prove it. So I will take it down. 5, 15, 32, 56, 87, and 125. Okay. So like we said, it should be quadratic, but let's try and prove it. Okay, so from 5 to 15, that's plus 10. From 15 to 32, that is plus 17, I think. Oh. Yeah, should have trusted myself. Right, so from 32 to 56, so I'm doing 56 minus 32, and I get 24. 56 to 87 is plus 31. And then 87 to 125 is plus 38. Okay, so that is no common first difference. So it's not linear. Okay, so we go to the second difference. From 10 to, oh, sorry, I meant to change colour, hang on. From 10 to 17 is plus 7. From 17 to 24, plus 7. 31 minus 24 is 7. And 31 to 38 is also 7. So we have a common second difference. So our sequence is quadratic. Okay, so that's the last one. Like I said, we were going to have one of each. So that's what you should have got. So exponential for the first one, then cubic, then linear, then quadratic. Okay, I said it a few times, but if for any reason you did not do the work, you've got to do the work. Okay, there's no point in just writing it down with no work attached. You just wouldn't get any marks for it. Okay, so Wednesday, 24th. Right, so we're moving into the second chapter on patterns, number patterns 2. There's a couple of words in there that you recognize. You should recognize start term. That's A. It's the starting term of the sequence, the first term in the sequence. You should recognize first difference. That's D. So that's when the first difference is common. So that's in a linear sequence. You should recognize nonlinear. We've learned 3 nonlinear graphs. We learned, not graphs, sorry, sequences. Quadratic, cubic, and exponential are the 3 that we learned. So you do know what nonlinear is. Oh, linear. So linear is when we have a common first difference. Then it's linear. So today what we're going to do, what we're going to concentrate on is this, the general term. Okay? Right. So there's a couple of names for the general term. So I suppose the first thing is there are general terms for all the sequences we talked about, linear, quadratic, cubic, and exponential. But you only have to do a general term for a linear sequence. You don't have to do a general term for any of the other sequences. So it'll only be for a linear sequence. Okay? General term has other names. So general term can also be called Tn. That's like a symbol for it. And another thing it can be called is the nth term. Okay, so it can be called the general term, Tn, or the nth term. They all mean the same thing. Okay, now what is the general term? So I suppose the general term is like a rule that will help you to find any term in the sequence. Okay, so you know at the start we were doing remember the ones where we did the colours and the shapes, and it was like oh, I don't know, find the 6th shape of the pattern, and that was grand because they'd given us the first 5, so we just did one more. And then it was, oh, find the 10th or the 11th, and it was like, that's okay. But then they asked us for like the 37th. And then we had to start looking at the multiples, so we had to kind of find a pattern within the pattern. So that's essentially what this is, except rather than you having to find the pattern, you just generate a formula or a rule. Okay? So if we look at this question here, they tell us that the general term Tn for this particular pattern is 5n plus 1. Okay, so what that means is you take a number, okay, n can be any number, so it's like a wild card. Okay, n can represent anything. N can represent the number 2, or it could represent the number 202. Any number. Okay? And what you're going to do then is you're going to take that number and you're going to multiply it by 5. Okay, so when two numbers are stuck together like that, see the way it's 5n, that means multiply. Okay, multiply is the only mathematical symbol that we can leave out, and we know what it means. Okay, if you want to add things, you have to put a plus in. If you want to minus things, you have to put a minus in. But if you want to multiply things, you can do this, like 6x. That means 6 multiplied by x. Or you can do 8n, and that means 8 multiplied by n. Okay, so when two numbers, or a number and a letter more specifically, are just stuck together, it means multiply. Okay, so what this rule says is take the number, any number, multiply it by 5, and then, that's quite straightforward, add 1. Okay, so that's the general term, that's the rule that's going to give us any term in this particular sequence. Okay, so what did they ask us for? They asked us to find the first, second, and 10th terms of this sequence. So if you want to find the first term, okay, that's what you've been asked, then you have to make n be 1. Okay, because the first term would be where n is 1. Yeah? If you wanted the 2000th term, then n would be 2000. Okay, so let's find the first term. So what we do is we write down our 5, because that's what comes first over here. Okay, next is our n, but now we're going to make n 1. So you can use a multiply sign. I'm going to use a bracket, because brackets mean multiply as well. So I'm going to do 5 times 1, and then the rest of the formula is plus 1. Okay, so what's 5 times 1? That's 5. Plus 1 is 6. So the first term of this sequence is 6. Okay, let's do the second term. Okay, so the second term, I'm going to make n equal to 2. Okay, second term, n is 2. So I have the same formula, which means it starts with 5, but this time I'm going to multiply the 5 by 2, and then I'm going to add 1. So what is 5 multiplied by 2? It's 10 plus 1 is 11. So the second term of this sequence is 11. Okay? Last part of the question was what's the 10th term? Now we'll look at the sequence in a minute, but let's just do the question. So the 10th term, I'm going to make n equal to 10. So the 10th term, n equals 10. So the same formula, I'm going to start with my 5. This time I'm going to multiply it by 10 and add 1. 5 multiplied by 10 is 50, plus 1 is 51. So the 10th term of this sequence is 51. Yeah? So let's just look at the sequence quickly, okay? So the first term of the sequence is 6. Second term of the sequence is 11, right? Remember that we only do general terms, and this question was given as a general term, so there's your general term. We only do general terms for linear sequences. Okay, so we know this is linear, right? So 6 to 11 is a jump of 5. So that means the next jump, if it's linear, is going to be 5. Okay, so that brings me to 16. And then I'm going to jump another 5, which brings me to 21. And then another 5. So I'm up to 26. Another 5 brings me to 31. Another 5, 36. Another 5, 41. Another 5, 46, and another 5, 51. Okay, and hopefully that works with what we should have gotten. So the first term is 6, which is what we figured out. The second term is 11. We've just done the third, the fourth, the fifth, the sixth, the 7th, the 8th, the 9th, and yeah, the 10th. So by just doing the sequence, I got that the 10th was 51, and when we used the general term, we also got that the 10th was 51. Okay? So that's how you use a general term. You will be given the general term. Okay, and it's a little formula, just like this. And then if you're asked for the first term, because n can be any number, if you're asked for the first term, you turn n into a 1, or you replace n with a 1. If you're asked for the 50th term, you replace n with a 50. And then you just do the operation. Okay, so I'm just going to... Okay, so here are a couple of questions. So the nth term or the general term of the following linear sequences are given. So there's an nth term, 2n plus 5. There's another one, 5n minus 1. In each case, can you find... So they want you to find the first term, so that's when n is 1. We want to find the second term, which is turning n into a 2. We want to find the third term, which is turning n into a 3. And then we want to find the 100th term, which is turning n into 100. Okay, so for homework, I would like you to do... Let's do A and B. Okay, I'm just going to pop this into your journal. So there you go, just A and B. Find the first term, the second term, the third term, and the 100th term for each sequence. So find all 4 of them using this formula for A, and then find all 4 using this formula here for B. Okay, and that's due Friday. Alright guys, thanks. Let me know if you come across any issues.